Hey folks, and welcome to week 10 of the Bring Back the Salmon Classroom Hatchery program. So far in this program, we've been learning about Atlantic salmon along with some negative impacts that humans have had and are having on the natural world. I want to stress though, that I firmly believe that we are part of nature. Everything we create, even things like a great big concrete building or a nuclear bomb, are from materials from the earth that have been processed by one of the earth's species, us. So this brings up a bit of a question. Are our negative impacts natural? Are the human and natural world two separate things, or are we one? If our negative impacts are natural, then so is learning from our mistakes, growing and having positive impacts. In fact, maybe our negative impacts are extremely important lessons for us to build a better future through positive impacts. One technique for having positive impact is ecological restoration. Eco is a Greek word that roughly translates to home. Restoration is the act of returning something to a former condition, restoring our home from negative impacts that we have had. The act of ecological restoration involves careful observation and understanding, having respect and a sense of responsibility. Thanks go out to all the many individuals, groups, and organizations that have taken on this responsibility of ecological restoration. The Lake Ontario Atlantic Salmon Restoration Program is restoring Atlantic salmon back into the Lake Ontario watershed. Humans having a positive impact in an effort to right the negative impact that humans have had. After our hatchery checks, Catherine is going to be back to teach us about the components of the Lake Ontario Atlantic Salmon Restoration Program, and then we're going to be hearing another fishy fact from Johnny. Okay, so we'll start with this tank. I've already removed the panels, and when I removed them, I saw some fish swimming around, and we might be able to find some here. There's one sitting out here on a rock. So we can see with this fish, it's gotten a little bit darker in color. And when we look at the other tank, you can really see that. So it's darker in color, and it's got spots on the side of it. Still has its yolk sac, but the yolk sac is getting smaller. So these fish are starting to move around a bit. We have to do something very important today. Probably something that I should have already done, but it's okay. We'll get it done today. And that is the intake for the filter. So this intake will keep out larger fish, but our fish are small enough that they can get sucked up and into the filter, which isn't a good place for them to be. So what we're going to do today is we're going to cover that up. Okay, so once again, I've turned off all the equipment because I'm going to be working in here, and this intake just pops right off. So we can see those slots on there, big enough for a fish. So we're going to put some screening. This is just window screening, nylon window screening, and it'll still let the water flow in there really well, but it'll keep the fish out. So put that on, use an elastic to hold that on, and this will keep our fish from getting up into our filter. And of course, we want to make sure all the equipment's working. There's the filter, there's the aerator bubbles, and our temperature is at 7 degrees. All right, and then with this tank, filter's working, bubbles coming up. The temperature is sitting right about 4 degrees, and pretty much every single one of them have hatched now. They're okay to stay in here for a while longer, so we might wait another couple weeks before we let them out. We'll have another big, exciting release day. All right, both tanks are going great. All right, let's hear from Catherine and then Johnny.
The program is built around 4 pillars that all have the same goal, to once again have a self-sustaining and naturally reproducing population of Atlantic salmon in Lake Ontario. The fish that we release come from hatcheries, and you may wonder where these fish come from, considering that we lost our Lake Ontario strain over 120 years ago. Though we would have preferred to use our local strain, obviously that's not possible. So we're using 2 strains from out east, the La Havre strain from Nova Scotia and the Sebago strain from Maine, with the hope that they will create a new Lake Ontario strain adapted to the lake's current ecosystem. Harwood Fish Culture Station keeps our broodstock or adult Atlantics and spawns them each fall. I know this looks kind of rough, but the fish are sedated so they're relaxed. Hatchery staff have cared for these fish all their lives, and so the fish's health is their priority. When the female is ready to lay eggs, the staff stroke her belly and then collect the eggs in a bowl. The milt from a male then fertilizes the eggs. The eggs develop in trays, and when they're at the eyed egg stage, they're delivered to our classroom hatchery tanks. The rest of the eggs are transferred to Normandale Fish Culture Station, where they are raised until they are old enough to be stocked into streams. We stock 3 life stages: spring fry, fall fingerlings, and spring yearlings. Spring fry are stocked in May. They've been raised at warmer temperatures and they've been fed, so they're much larger than the classroom hatchery fish, which are released at the same time. The hatchery truck arrives at the stocking location, and the fish are netted into bags, which are filled with oxygen. The oxygen diffuses into the water, which allows the fish to breathe, even though there is little water in the bag itself. Volunteers then carry the bags, sometimes floating them downstream, and release the fish. The fish quickly orient in the water, facing upstream. In the fall, we stock fall fingerlings, or parr. These fish are much larger, so we can use hose stocking, where we connect a hose to the truck and then pump out the water and the fish. These larger fish then disperse throughout the stream. In early spring, or 3rd life stage, spring yearlings are stocked. These fish are over a year old, and most will smolt soon after stocking, swimming downstream and entering the lake. Of course, we don't want to put fish in streams that can't support them. So our second pillar is habitat and water quality enhancement. This means that we do projects ranging from tree planting and garbage cleanups to enhancing cattle crossings and dam and pond mitigation. Picking up garbage is an easy activity that everyone can do. By removing trash from the ground, you're preventing it from being washed or blown into the stream. Trash in the water might be eaten by aquatic organisms, pollute the water, or be carried down to the lake. Humans also enjoy areas more when they look clean. Plus, you'll never know what you find. Tree planting has a ton of benefits. It's the best way to stabilize banks because tree roots bind soil together. Tree roots also filter pollutants that run off roads, agricultural fields, and lawns, helping to clean the water. They also hold onto water that is absorbed in the soil, reducing the effect of heavy rainfalls and releasing water during droughts. Trees also provide shade. Have you ever stood outside on a hot day? You're hotter in the sun than in the shade, right? Same thing happens with water. Fish cannot regulate their body temperatures. They are ectotherms, meaning their body temperature is dependent on the external environment. That means if you heat up the water, you heat up the fish. Some fish, like Atlantic salmon, require cold water to survive, and cutting down trees has led to an increase in stream temperature that harms these fish. Even when trees fall down, they create important habitat for both the fish and the invertebrates they feed on. The great thing about planting trees is that they help fish no matter where you plant them. A tree in your backyard or by a parking lot will help keep the ground cool, which means that rainwater will be cooler when it travels over the ground and enters the stream. Here's an example of an old bridge crossing on a golf course that was disintegrating. The culverts were clogged and too high, which was not good for fish movement. Staff were able to remove the bridge so that the stream is now accessible to all fish and invertebrates. And even the old concrete was put to good use. We created fox dens and garter snake hibernaculums to provide habitat for these animals that would in turn control rodents. We have also helped to remove several man-made ponds. Ponds like this create a large area of slow-moving water that is not shaded, which warms up the water flowing downstream. It also holds back sediments, including nutrients that are necessary for primary producers downstream. Staff drained the pond and created a new stream channel. Then they planted trees to stabilize the newly created bank. We want to make sure that what we're doing is working, and so research and monitoring is an important pillar. Aquatic animals require specialized equipment to sample safely. Electrofishing is a standard method for assessing fish communities. Basically, we're using electricity and water in a very controlled way with lots of safety features. Do not try this at home. But trained staff can use this method, which temporarily stuns the fish. We then catch each fish, which means we can identify, count, and weigh how many fish are in a section of stream. This tells us not only how many Atlantic salmon are there, but also about the entire fish community, giving us an index of stream health. Other methods of monitoring that we've used include smolt traps, which capture a proportion of the fish migrating downstream, and funnel traps, which capture all the fish in smaller streams. Researchers empty the trap, collect the fish, and identify them before releasing them downstream. Sometimes you want to know more about individual movement, so you may mark the fish to tell them apart. This individual has some dye injected. Let's call her Daisy. If they catch Daisy again, they'll know how far she traveled and how much she grew, which will give us more detailed information about what she did. Another habitat project involves dams. Dams block fish movement. For some dams, there are fish ladders installed. A fishway is basically a ladder, where instead of one big jump, fish have to make several small jumps to get past the dam. In 2 fishways on streams in southern Ontario, we have cameras installed. These cameras take a video of every single fish that migrates upstream. That allows us to identify and count every single salmonid, including Atlantic salmon, that migrate upstream. Sometimes there are over 20,000 fish that have to be counted and identified in these videos. That's a lot of work. And sometimes we see other critters also swimming past the camera. We want to create new environmental stewards, and so our 4th pillar, education and outreach, includes the Classroom Hatchery program. Our goal is to educate young people about the mistakes of the past and inspire them to have good values to prevent those choices from happening again in the future. We also do outreach at a variety of public events, including conferences, naturalist clubs, fly fishing clubs, and universities. The public can also support the program by adopting an Atlantic, where you can name one of the broodstock and contribute to ongoing research. So that's a brief overview of how our program is structured and the types of activities that we do. We couldn't do these projects without the help of partner organizations and volunteers. Stocking spring fry and tree planting both involve numerous volunteers to help us get those fish and trees where they need to be. So as you walk around the landscape, perhaps think about those small things you can do to help these fish. Pick up the trash, make sure it ends up in a garbage, and perhaps get involved in tree planting or garbage cleanup activities in your neighborhood. Lots of little things can make a big difference.
Hello everyone. Thanks for tuning into this week's segment of Fishy Facts. I'm Johnny Nene. This week, instead of talking about a specific fish species, we're going to talk about an interesting biological structure that fish have: otoliths. Otoliths are found in all vertebrates, including fish, except for sharks, rays, and lampreys. In fish, they are located in fluid sacs of the inner ear below the brain. Otoliths help fish to hear and maintain their orientation in the water. They are made of calcium carbonate, and material is added and never taken away as individuals grow, and so they are actually considered stones, not bones. Fish possess 3 different pairs of otoliths. The largest pair are called sagittae and are often used by fisheries managers for determining a fish's age. By taking a slice of an otolith and analyzing it under a microscope, we can determine a fish's age by counting annuli, similar to the rings on a tree. Annuli means annual, and the annuli are comprised of daily lines that are closer together in the winter, resulting in a dark band that is interpreted as 1 year. This information is crucial to understanding population structures and growth rates in our fish communities. Otoliths also contain trace elements from where a fish lived, and as such, they can be analyzed to reveal habitat information. In fact, scientists have used fish otoliths that were 172 million years old to reveal historic climate information from the Jurassic period, when dinosaurs roamed the earth. Well, that's all from me for this week. Thanks for checking out this week's segment of Fishy Facts. I'll see you guys next time.
Thank you, Catherine, and thank you, Johnny, for those great presentations. And thanks again for watching the Bring Back the Salmon Classroom Hatchery program. Be sure to join us next week when we're going to be hearing from 3 different conservation authorities about how you can help protect your watershed.